why we have the 150AB slash the CIS 105, CIS 156 together in one course. And I'm going to do that by just opening up. You all should be able to see the screen here. I'm just going to open up the competencies here. And if it doesn't allow me to launch, I'll launch it in another menu. See, there we go. So in another tab, we have the course competencies, which will be also listed in the syllabus if you've had a chance to look at that already in the course outline. So CIS 150AB is a kind of an introduction to programming fundamentals, but for object-oriented programming languages. Sometimes you see that as OOP or OOP. So what that is being able to take objects such as a string or a integer value, or create your own objects, like maybe you call it a car because you're going to be working with different types of make and models or things like that. And how do you program that and use methods and create special functions for that? That's kind of a general what that is about. But if you look here, we're learning like some basic parts of computer components and operations, so how things tie together, the different number systems, ASCII code, Unicode, software development cycle, a couple other project-oriented procedures, inheritance, some other things here that many of you probably will be like, I don't really understand what that is. But if I were to go back to the other class, see, you will notice that in a much simpler tone, this is going over the same thing. The only difference is we are doing it specifically in Python. So we also have to learn more about the history of Python and why it is the way it is. In the other class, we can pick any language we want to do so. So why not combine the two together? And another reason for us combining it together is because Python is a great first language for people. And so if you're just coming into object-oriented programming and just want to learn the fundamentals, why not learn Python? It's also one of the most widely used languages in the world for various reasons and in various fields. If you do like some research, I still see sometimes it'll say like, no, Java really is. But I highly doubt that because I know many companies that are moving from Java to go back to C or C++ or C++ or C Sharp, or that are moving their things over to Python. And there is actually a way for you to code Java within Python. So why not just use Python? But there are some reasons why you wouldn't, and we will get to that as well. So that's the reason why these things are combined. If you sign up for 150AB, guess what? You'll get credit for 150AB at the end. If you sign up for 156, guess what? You get credit for 156 at the end. There's no like, oh, I got both of them for this. So depending on what degree that you were going for, you hopefully signed up for the correct one. If not, we could make some substitutions so that that wouldn't affect you in any way. Double dipping, that would depend on the program director if they would be okay with that. But usually when that happens, like if you need to take 150AB and you need to take 156, and in this case you took both, or they're really the same course, usually, so I'm not saying this is set in stone, but whoever is in charge of that program director, they may say, yes, I will allow this, but you have to take this additional class to make up for the credits. So that's everything with the reason why we combine with that. So now I kind of want to give a little overview of who I am and allow you guys to interview me and ask me any questions that you may have. It could be about the course, it could be about me, my life, why I'm doing this, things like that. But I am Christopher Stevens. As I said, I prefer to be called Professor Stevens. And I am from Georgia, a little town called Macon, Georgia, if anyone's ever heard of it. That's where Otis Redding is from. His wife actually still owned, well, I don't know if she still has it now because of everything going on, but she used to have a shoe shop where she would sell glorious clothes and all this stuff that I, as a young man, would have to sit while my mom would chat it up with all the other women in the store, and she would buy various items. But we would go there like at least once a week. So, I am a program director at South Mountain for Office of Applications and Technology Support, and I am also one of the program directors for mobile application and programming development. So, for instance, what this course is about, it's about programming, and it can help be a great foundation and building block for those moving into mobile app development. But this language can help you move into data analytics, It is key in cybersecurity. It is very helpful even in web development. Even though it's not one of the courses in the track, it is very helpful on the back end when it comes to web development. So it has its hand in many different aspects when it comes to CIS and just in the world in general. So um, that's who I am in a general sense. Does anyone have any questions particular for me? And I love this time, so don't feel like you shouldn't say anything so we can move on or anything like that. Go ahead and just ask me anything you want. You can unmute yourself to ask or ask in the chat. Okay? No one? All right. No questions. Okay. Well, I give us a little more time. Nothing. All right. Well, wanted to oh, how am I doing? I am doing great. I'm happy to start the semester off in a great way. This is my first time being able to teach this course at South Mountain, and I am so happy to do so. Python was my first language. That's actually another question someone asked. How long have I been programming in Python? I began in the fall of 2007, so 13 years ago. Uh, Pretty close to the date, actually. I began programming in Python and it was actually kind of like it was the I think later on I'll talk about this. Like Python is kind of like the gateway drug for a lot of people when it comes to programming because a lot of people will think that oh it's too hard, it's rocket science, or oh no I can't program, I'm not smart enough, or I can't do da da da. And because of how simple they laid out the language, which is funny, they've continued to do that over time with different programming languages like Basic. Even when they went from C to Java and so on and so forth, they always try to make things simpler. And when it came to Python, it finally clicked for me. And then once you know one programming language, it's easier to go back and learn others because you understand the general idea of programming, and then now you just have to translate. It's like we all can talk to one another, we can communicate in some way. Now we just have to fit it into the right language. So if I need to speak to someone in English, I'll pull an English dictionary, or nowadays we'll just speak it in Google Translate and it'll translate for us into any other language. It's just like that. Um, Technically, I like to call Python my first language. Technically, it was not my first language. That was another question from someone. Um, my first language was was this language called Delphi, which I took a summer before, like, well, I guess technically 2 summers before I ever learned Python. It was a requirement of the summer camp I was at for doing math, because math is my first love, and always will be. Programming is my second now because of Python. Actually, is what it started at, but um, I learned Delphi, and it was to create. Pretty much, I created this program that allowed someone to put in any polynomial or to put in any number if they wanted to define any root they wanted. And I absolutely hated it because I had no idea really what was going on. Um, let's see, where did I go to school? The Georgia Institute of Technology, also known as Georgia Tech, which if I can, I don't know if you guys can see that properly. If you ever saw me on campus, I would probably have a bunch of Georgia Tech stuff on in some kind of capacity. Even my shoes have Georgia Tech on it. I absolutely love that school. When I was in second grade, my second grade teacher told me that I was good at math, so I should go to Georgia Tech and be a mathematician, and that's exactly what I did. So, which is a funny note. If you have any young people around you, they are very impressionable, and they will probably do stuff that you tell them to do, and they'll never forget it. So, don't know if you answered this already or not, but I don't see the class in my um learning section. I do not do not know what you're referring to when you say you don't see it in your learning section. Um, so whoever asked that question, if you could clarify that in the chat, that would be great. Do I have any certificates? Currently, I am working on the Google IT Support Certificate, which has been set to be a gateway into A+ certification. So for For those that don't know what A+ certification is, it's for being able to uh, build computers. So you can think of it kind of like a hardware maintenance. Software is a part of that as well, because in order to have a running computer, you need hardware and software. We need to know how to integrate. So we have 2 courses at South Mountain that you could take to help prepare for A+ certification. Um, and it's because we're not using. Yeah, we're not using Neticat. CCNA, I do not have any Cisco certifications. That's a future, I don't even want to say desire. It's like one of those things that'd be cool to do. It's not something I'm like solely going after, because that's a huge commitment. I've seen other faculty go for it when they're teaching, same amount of load that I am. So you're supposed to work a minimum of 50 hours, which we're usually going above whatever that minimum is. And then on top of that, imagine trying to sit for 8 weeks straight to cram for each the first class and then the second one, and then you have a third one the next semester. It can get kind of tough, but I do plan to do that sometime point in the future. There's a couple of faculty that want to do that together. So who knows? You guys, one of you could end up being our instructor in the future for getting CCNA certified. And if you don't know what that is, that's for Cisco networking, and that's the associates part. So yeah, but yeah. So the only certificate that I currently have when it comes to technology certification or working on actively would be the Google IT support. I probably would be Excel specialist, or actually probably at this point expert certified. I just haven't taken the test because I haven't had time to. Access as well. Python probably could do the same thing. Just got to have the time to do it, and I really would like for someone else to pay for it. So if you ever see an administrator on campus, just don't mention my name, but just say, hey, you guys should pay for this. You should get certifications. But I am also looking forward to doing cloud computing. That's something that's going to be new to South, and we have only one person that can teach it. So while I only have one person, we're going to have more than that. And I had to do a lot of work last semester due to everything happening and us being pushed to online, so that students would have the availability to use a Windows computer no matter what kind of device they were on. So I had students on their iPhones that were working on a virtual machine that which I created the workspace for, and I had to go through and do 147 different workspaces. Which once you do one, it's fine. But then there was issues where I wasn't the admin, so which was cool. So I actually used a Python. I created a Python program to actually go through and build all the credentials for each person, so then it would just automatically populate in. But that being said, because I had somehow lost my admin rights, I still had to individually put in each person's thing. So, but it automatically created all the everything I needed. So I just pretty much had to copy and paste at that point. But that was fun because I got to use Python in that way. All right, cool. See, people did have some questions about me. All right, anything else? Any other questions about me or about the course, about Python? All right. Well, I actually do have some questions for you. And since there's about 11 of us last I checked, I don't know how many there are now. There are 4. Great. We got 14 now. So I'm not going to ask everyone to introduce themselves, although I would normally love to. Actually, maybe we will. But right now, I really want to get to know you from my end for like what other courses you're taking, what degree plan you're going for, or maybe you're just taking this just to dive into Python and see what it's all about. But if you go to your Canvas page, you will see it'll say CIS156 entrance survey. Again, that is for everyone, even if you're signed up for 150AB. I'll open it here so you guys can kind of see. This has 2 points. The main focus of this is for me to kind of know more about you and what you want out of this and why you're in this course. The other part is because we have to have some kind of way to say that, hey, I know that so-and-so showed up for this class the first day, so don't kick them out. But general stuff, what's your name? What do you prefer to be called? Like, my name is Christopher. I prefer to be called Professor Stevens. Contact information, and I'm gonna keep that to myself. Won't give it to anyone else. And if it's okay to text, During the summer, I taught a iOS course with Professor Histetti, and there were many times where I needed to text someone because they didn't reply back to the emails, they didn't answer the phone, which understandable, But when I texted, it was like that. So, not saying you have to say it's okay to text. Definitely not saying that. But if it's something you are okay with, it usually is the fastest way that people communicate back to me. And then only time I would text would be in regards to, of course, the course. So, what are your goals with this class? What are you majoring in? Uh, I know recently, because cybersecurity and networking added Python to their required courses, we've had an increase in that. We've had whole sections sometime would just be students going in for Cisco or some other networking or cybersecurity certificate or AAS degree. So how well do you already know Python? Some of you may have gone into the Code Academy course and you pretty much could get the first half, if not more, of this course already down. And there are a ton of other ones out there as well. If you know how to manage files, so can you open up File Explorer? Know your way around there, how to how to search for a file if you don't know where it is. You know how to open them up. You know how to surf the internet. Do you know what a zip file is? And if you do you know how to compress files into a zip file? Do you know how to unzip them? And then again, here it is. Why are you taking this course? What is your computer situation? What kind of computer do you have? As you know, we are in a time where you can't just go anywhere to get online like you could before. So the library is still closed at this point. The computer commons will be open at limited hours and at limited days. I have put the information in your syllabus, but it is limited, and there's also a limit on how many people can be in there at a certain time as well. And if you've ever been on campus, you will know that when you sign into a computer, you want to pretty much go to the exact same one because it will take forever for it to create a new image of you. Because if you go to a different computer, it's not connected to the other. It doesn't know that, oh, Christopher is this person still because he signed in with his email ID and password. No, it creates a brand new image of you on each computer that you go into. So it takes a while. So you want to go to the same ones. Well, with things being limited, that may not always be available. So I'm asking this for other reasons too, just to help with resources. Because you can download Python on your Windows, you can download Python on your Mac. You could work with it literally on any computer, and I'll tell you guys how a little bit later. What type of mobile device do you have? And this is kind of also in case some of you are in this class because you're going to be going down the track for mobile app development. So you may be going to iOS or Android or Windows programming. And this is kind of our way of just seeing what do students have on campus, especially if we create applications for you all. And just acknowledging that you read the syllabus. Yeah, so that's what this is. And you guys can get to that. And while you're working on that, I'll go over the syllabus as well, because that's the last part. You have to acknowledge that you've gone through it. So, all right. So the course syllabus, we have 2 courses wrapped in one. Professor Stevens again. Here's my cell number, my office number. Of course, I can't actually be in my office because I'm not allowed on campus at the moment. So it's forwarded to the same number. So guess what? Easier just to contact the first one. You can text to that. It will be a while before I see it. Just to be honest, and it may not be. I may be right in front of it. So, but I will get back to you. I always tell students it's probably better to call this number or text, and then email after, especially if it's somewhat of an emergency, because then your question can get answered a lot faster that way. Office location, it's going to be online. It's going to be in the same personal meeting room that you access through WebEx in the link. So you all know how to get there now because you're here right now. One other thing I'll say about WebEx that I do like is that these personal meeting rooms, like some of your other instructors may be using a set meeting room that's not a personal meeting room that's only for that class, or they may set up a WebEx event or a WebEx training or something like that. I like to keep things as simple as possible, and I stick to the meeting room because I will never exceed the amount of students that will need that I can have in here. and it's a one-stop shop. I can give you guys a direct link. I don't have to worry about each week setting up a new meeting, making sure it records and where did it save it to. It all goes to the same exact place. And you can have you all have personal meeting rooms provided to you by the district, by Maricopa Community College District. Every person that has a student ID has one. The reason I can access mine is through my student ID. It's not through the fact that I'm a faculty member or anything like that. Every person has an MEID at maricopa.edu. That is the account that you use to sign into WebEx, as you guys saw today. And that account has a personal meeting room. So if you wanted to set up your own personal meeting room, you could just give the link to someone. Yours should be similar to mine, maricopa.webex.com/meet/ whatever username WebEx decides that you should have. You will be able to find these recorded sessions. I'll post. That was a question, by the way. Someone asked, where can you find the recorded sessions? You will be able to find them in Canvas. I try my best to put them above where the topic is of what will follow. So I will put this at the very top in week 0 of the week 0 module. Let's get started. So I would put it there, and then I will also put it in an announcement and an email. So I try to give it to you guys in 3 or more ways, so that way there's no excuse. That's also why you saw the WebEx link sent out to you in a Google Calendar invite and an email, and it also was in the syllabus, and it was in like one of the first announcements. And even on this page, see how it was written 5 times in a row, because I want to make sure everyone knows how to get to something. So there's no question about it. But yeah, so you all have access to your own personal meeting rooms that you can create, not create, but you can have and make the link available to anyone anytime. The great thing about that is that you guys can have your own study sessions for not just this course, but any other ones. You can invite an instructor to that, or different instructors if you wanted to. So you have the power to have your own meeting at any point in time. So I say use it. My office hours are Monday through Thursday, 4 to 5:30. So about 30 minutes before this class starts on Monday. So if you wanted to, so if I don't even knew no one logged in earlier, but if you had, you would have seen it. I was here from 4 to 6 straight through. I didn't turn it off at 5:30 or anything like that. So I try my best to do that so that, especially for you all, because you may have questions from like the week before, and it's been a whole week since. For some people, it may only be a week before you can even get back in here or have a chance to even ask me anything. So you'll have that time before class starts to do so if you want to take it. And classes will be held 6 to 8:30 on Mondays, as you all know, because you signed up for the course. One thing, and I forgot to mention this in my other class before, but when it says office hours, we've discovered that students sometimes, when they hear office hours, they hear, oh, that's the time for the instructor to do, some grading and, their alone time in office. That's not what that's for. That's for you. That time is set aside for you. And I know some instructors have started calling it tutoring hours. But I didn't want to do that either, because I did do that for one class, and everyone thought that meant that that was the time to go see the tutor. It's a time for you to be able to communicate with me. So please take hold of that. It's not for I'm going to be by myself that whole time. If I wanted to be by myself, I would set time aside, which I do, and put do not disturb. I wouldn't be logged into the WebEx personal meeting room to just be by myself. It's for you all. So use that time if you need. So we'll be meeting this WebEx. It's starting from today until December 18th. That last week of the 18th, I think it's the 13th or 18th, that's designated as finals week. There is no final for this course. There will be some projects that will be due on that Sunday, but you could be using that time to go back and redo some projects that maybe you didn't do as well on, or that you want to have a better grade on, or try to see where you can improve your grade. There won't be any personalized extra credit that I know some people sometimes ask for. I don't do that. There's enough extra credit built into any course that I ever have. So the purpose of me doing that is so I can avoid that situation, but also so that you always have an opportunity, and there's never oh, well, I didn't have enough time, or wasn't given the opportunity to be able to get my grade from a B to an A. There's way too much. So no excuse. And you will see when we get to the assignments that there are 20 believe I had 24, 28 assignments listed. They're already all there. However, I may add more. That's not for I have to do more now. That's for I have opportunity to test my skills more with these assignments, and you don't have to do them. And well, I'll explain why a little bit later on. So there's our general course. Oh, does someone have a question? Okay. All right. General course description for both courses. Uh, your student learning outcomes. So this is what you should expect to get from this course. You should be able to write Python programs that process user input and display formatted outputs. So take in user information and format it into the way that you would like for it to be outputted or shown on the screen to someone. Write Python programs that utilize control structures. So it says conditional or repetitional. Develop Python programs that utilize standard and or programmer defined methods. Develop Python programs that use advanced features such as lists, tuples, data handling, object-oriented programming, GUI controls, etc. And so we will do that, and we'll get to that as we move further along. We're going to build on the basics the first couple of weeks, but some of these things I will kind of name drop throughout. So there are the competencies listed. I showed you guys that in the link originally. Required course materials. I think I got an email, and I feel like I responded back to it, so I hope it was clear. What's the textbook for this course? Well, there is none. That being said, I will refer to a couple of different books that people have created or PDF files or guidelines. There are hundreds, and I mean hundreds of them. You could just start simply by going to python.org and seeing what they have for documentation. They have their own online tutorials. They have tons of information just there. But from that, because this language has been around for so long and is so popular and has so many uses in so many different avenues, there are books that are very specific. I've been looking into one on data science recently, one on statistical learning as well. And I'm like, well, there's no reason for these people to create two different books because they're talking about almost the same stuff for the most part, but it's still there. And so here are four that were picked out actually by the previous program director for this program, and that was Stephen Hastedi. But they are great resources and they are free. So I always try my best to find the free ones. If you actually have an iPad and you have books from Apple, if you just type in Python, you will find a couple of free ones there as well that you can just run through. They're a lot of fun. Codeacademy.org, DataCamp, Solo Learn, Jupyter Notebooks. I can go on all day, and I'm gonna try not to. But sometimes I will send out announcements about, hey, check out this site if you're having trouble with this, or check out this video, because there's so much information out there. But having so much information can make it harder to find exactly what you want. So I'll try my best on my end to do that for you. So, and I have links here for that, and I have them in another place as well. So I would suggest saving your files on a USB drive or Google Drive. If you have Dropbox, whatever way that you like. The reason for that is so that you always have access to them. I tend to save my information in two places, and I've learned recently that that's not even best. I could go better. So on the computer directly and on because it's my own personal, but if I was ever at the school, I'll always use USB, and then secondary would go to Google Drive. But I used to also use my external hard drive, and then I lost both at one point. So yeah, that was not fun. But thankfully, I had some things in Google Drive that I was able to bring back down. So there is a limit on Google Drive. So there are ways around that. Buying it is probably the better option. Sometimes if you have a true reason to create another Google account, you can do it that way. But otherwise, just buying the extra space is fine, and it's not that much. That's just a general suggestion. So make sure your computer has high-speed access, which you all do, otherwise you wouldn't be able to be on this call right now. Software, you will need Python 3.6 or greater. When we go to installing Python, when you go directly to python.org, it's at 3.8 3.8.1, I believe, right now. So that'll be pretty easy for you to find that. Um, let's see. If you don't want to use that, there are other options as well. And I have a list here, Microsoft Visual Studios. For those of you that are taking another programming course already from South Mountain, you probably have used Visual Studios. And those of you that will be taking future ones, you may need to have Visual Studio. So it might be a good idea to just install that and work from there. JetBrains is a very popular platform that people use. I have had to use JetBrains for some courses that I am taking myself um, for use in Python and R. And whenever I am doing Android development, Kotlin was actually created by them. So, of course, I would have to use their product. So that's another good one that you may just want to go ahead and download and use, especially if you're going in that route of into Android development. That's just a suggestion, not something you have to do. But the Computer Commons, if you don't know where that is, that's located in the TC building on campus. Again, they will be available for limited hours in days, but it will be available with limited number of computers. They do have Mac computers and Windows computers there. If you are using a different machine, such as a Chromebook specifically, you will not be able to download Python directly on the machine. However, you still can run it. There are lots of apps that are available, even if you don't have the availability to use Google Play on your Chromebook. There are still some apps that you can download and be able to write and run code on your Chromebook. However, it will not. It will run in its own IDE environment on a browser, not directly on your machine, unless you go into developer mode, which is not difficult to do. You can find tons of ways to do it. I just don't suggest doing it, and Google doesn't suggest doing it because it opens up the availability for the user to mess up the Chromebook, and also opens up it closes down some security features so that people could invade your machine. So I don't suggest that. But more recently, Chromebooks have begun to have what's called a Linux beta version, which allows you to run both the Chrome OS and Linux. And it's just pretty much kind of a switch between the two. And whatever you do on the Linux one, it's not connected to what you do on your Chromebook. So it makes it safer again. So if you have one of those, then you're good to go. Okay, so let's look into grading and how this runs. So as I said, there are a ton of different assignments available to you in this course, but the way that we grade, I believe there's 75 points available. Each of your assignments will be graded based off of those student learning outcomes we mentioned above. So let's scroll back up real quick. So these 4 items. So when I look at your Python file, I'll say, well, did he process, user input, and display format and output, and there'll be rubrics for there as well so that you can see which of the student learning outcomes we're looking for in each of the assignments. But that's what I'll do. I'll look to see, did you do this? And then you get a point for yes or no points for if you didn't. There's no like in between. It's either just a yes or a no. And if it's a no, I'll give details on why I say that it's a no. That way you can look at it and be like, okay, I know what to change so I can resubmit. Or you can look at it and be like, I feel like I really did do that. And then we can have a discussion, maybe in your own personal meeting room or through email. In those instances, if there ever is a request to regrade, I suggest set up a personal meeting room and we meet there because it's easier for us to both verbalize that way, I feel like, as opposed to going back and forth through emails because things can get misconstrued through email and through text. So with that being said, 75 points available at minimum right now. There could be more. Usually whenever I do one of these classes, there ends up being more opportunities than that. You only need 50 points max to get 100%. But that's broken up based off of these student learning outcomes. You would need at least 15 points from the first one, 15 from the second, 7 from the third, and 13 from the fourth in order to get that. Okay, so Yeah. And then based off that, the points are then they convert to these grades. So it's out of 50. So you can think of it that way. 50 is 100. So whatever, how many points you have in the end, double it, and that's your percentage in this course. So attendance. So the way I do attendance is based off of activity, because you could sit in this course right now, have your video, you can even have your video on and never say anything at all. And never ever talk or ask questions or anything like that, but you're active in class. If you don't ever turn any assignments, then no, you're not. So, based off of financial aid eligibility, what we have to do is, if you are not actively participating in a course for 14 days, you are dropped from that course. I have only had one instance where a student was dropped for not participating, that they begged, got back in the course afterwards, and passed. Only one instance. I've had several that have told me they're going to do such and such work, and I don't even want to go into what would even take for me to try to get you back in this course, because I don't even want to give the option of that this is something that's going to happen. I expect for everyone to actually participate by doing their assignments, by being in the course, um, on Monday from 6 to 8:30. If you have to leave earlier because you guys have work commitments or stuff like that, I understand. Just let me know ahead of time. If you're gonna be a little late coming in, same thing. Just let me know. I'm not evil. I'm not what do they call those guys that crack the whip. I'm not one of those guys. Um, I'm just here to help you. That's the only reason I'm here. That's the only reason I'm teaching, is to help people learn stuff so that they can be successful in what they want to do. So, um, excuse absences, same thing. Just kind of let me know if there's something that, like, a medical thing comes up. So, especially with stuff going on now, I will ask for documentation. It's not because I don't trust you. It's just we need to have some actual proof, because especially what's going on now, anyone and everyone can say, "Oh, well, I was sneezing, so I had COVID-like symptoms," which could be true, or it could just be, trying to make an excuse to get out of doing work. So, um, it's just a matter of honesty. And if you have an issue, should be no trouble getting medical documentation. Um, so withdrawals, October 5th, I want to say it's the 45th day. So before that, if you wanted to, you could, if you stop attending before then, you could get a W. Or sorry, if you stop attending after that, the only options you would have would be a W or a F. So you can withdraw yourself up to a certain date. I believe that appears on your student center, um, but otherwise you would have to discuss that with me. So that computer commons, like I said, is open. There's also tutoring available. It'll be available online and in person at that computer commons setting. Um, so the in person is going to be limited. As I said, I will have my office hours available from 4 to 5:30 Monday through Thursday, as well. So that's also available to you. The Learning Resource Center, they will not be open. They will have their tutors available online, and that information is also was given to you guys. Let's see. Disability services. If you feel like you may have a need of accommodation, you can contact Catherine.Pettit at southmountain.cc.edu, or you could give her a call, and then she would follow through with testing and things like that and documentation, so that you could get whatever it is that you need to be successful. So, student responsibilities. You're responsible for, honestly, just doing your assignments and putting your best foot forward. A great friend of mine used to quote that if someone gave her 5% of effort, she would provide the other 95%. I'm not as lenient as she is. I feel like, just because of how busy my life gets, there have been points in time in my life where if you gave me 0.5% effort, I would provide the other 99.5% to help you get to where you need to be. But nowadays it's more like a 20. You give me 20%, I can provide the other 80%, just because I know where what other responsibilities I have right now. So I say that just because to let you know that I am here to help, and I really will do everything I can within my power to help you understand and get to a point of success. Not just like success in regards of, oh, this kind of grade in the class, but success in regards of you having the confidence that you can do, well, in this case, you can program in Python. All right, so we're using Canvas. Your student email, make sure that you use your Maricopa email for communication. And I will, like I said, I'll be sending recorded sessions out to that as well. So it's good to know how to get there. It's pretty much just go to google.maricopa.edu. I have a link here just to help you get through that as well. Honestly, the rest of this is pretty much generic stuff. But when it comes to working in class, the recommendation is to use at least 9 hours of on average a week, 9 hours for this course, because it's a 3-credit course. Usually if you take the number of credits for your course, multiply by 3, that's how many hours on average you should be spending on it. So yeah, that's the basics of everything. Any questions from the syllabus, or anything that you may feel will be is missing? Of course, the syllabus is up for revision. I won't be changing the amount of points, except for maybe the total amount of points that are actually available. It may increase from 75, so I may update that. If I ever update the syllabus, it will be announced, and usually I email it out as well. So in announcements in Canvas, and also I'll email it. Okay, no sir. Sweet. All right. Well, it looks like we're ready to get started. Some of you may have already installed Python onto your machine, but that's the next thing that we want to do. We want to install Python. Now, like I said, there were a couple of different ways to do that. The easiest one in my mind is just go to python.org. So I actually, in week 0, options for installing Python, I put a couple of those links so that you could see where you could download these options directly. So I'm going to go to this website, and I'm going to download Python. So python.org. And if I go to downloads, oh, it's at 3.8.5. Okay. So a newer version than the one that I saw before. So from here, we can do is you can, like, as you notice, it goes straight to download for Windows because it's recognizing my machine. But if I wanted to, I could go to Windows here. If I wanted an older version, like I said, we'll be using 3.6 or higher in this course. But if I want an older version, I could just click view full list of downloads. And if I did that, you will see, actually, I'll just show you. And you might be saying, well, why would it matter? Just always get the latest. That's not the case. Depending on what you are doing for a course or in a field, you may need to have a specific version. You may even need to go to Python 2 instead of Python 3. So that's something else to keep in mind. So as you can see, here are our specific release versions here. So if I wanted a different version, I could go through here, and they're in order from release date. I can go here and download the one I wanted. So in my case, I'm going to go back and just download the newest one, 3.85. So, I open up that executable, and in my case, okay, looks like mine was already installed. Before this class started, I actually was working on uninstalling it. However, I am on a school machine, so I don't have full rights to do so. So I kind of faked the launcher and some other things. So the launcher was gone. I'm about to make sure that that's there. But it should be a pretty simple way for you to follow through. Okay. So even mine's not even letting me, but I already have a version of this installed, so it'll be okay. But whenever you install, you may have an option that asks for you to install, and you don't have admin rights for your machine. Python should allow you to install even though you don't have admin rights for your machine. There should be an option for when you install that pretty much is allowing you to say only for my user and not for the others on this machine. And that's how you can get around that if you don't have admin rights for your machine. So for instance, if you're borrowing a computer from the school, you'll need to be able to use still do this course. So that's what you would have to do. You would have to install for just your user and not for all users on the machine. So go ahead and install that. And once that gets done though, oops. So, oh, my other one's gone. Yeah, so once that's done, what you'll see is you'll have a Python 3.8 here. So that's what you can work from, and we'll get to that in a moment as well. So, is everyone okay? Oh, do Mac users run into issues compared to if were coding on a Windows? No. There should be no difference based off of where you're a Mac user or a Windows user when it comes to running this. The only issues I've ever seen in the past have been how to run things, because you have to sometimes run and install certain packages for Python. When I say package, it's kind of like other special uses that you can do in Python. Like I said, there's a lot of different avenues and a lot of different fields that Python's in. So sometimes there's these special packages that you'll need to install. And the way you do that on a Windows computer is usually easier than on a Mac computer. And when I say easier, it's because it's pretty much like this. I download, open up executable. There's a special GUI that comes up, and I can just click next and check what I want installed and things like that, and then I'm good and done. The Mac, I may have to, and they usually have documentation to show you, but pretty much it's like copying certain lines into your terminal on the command line so it installs things properly and puts it in the correct, and you have to tell it what folders to put it in and things like that. So that's the only issues that I can think of. In regards to runtime, I have run lots of different tests doing the same thing on a Mac versus Windows and Python. Um, Honestly, it was back in the day we used to bet on it, which would be faster and better. But everything would always run faster on a Mac. Now, we even had Macs from like from like the 80s, and they would be super slow in comparison, which makes sense, right? But um, now what we see, and even if you look at a computer from back then, that would be from Microsoft, or I guess in that case, technically IBM, um, versus a Mac at that time, the Microsoft machine would always win. Now, the Mac usually is faster at runtime. That's not saying that the Mac is a better option or anything like that. It's just is what it is, and that runtime is like microseconds that you won't even realize sometimes. But that's the only thing. Okay. So let's see. Okay, cool. You guys should be installing that. Did anyone run into any issues with installing Python? Uh, Heard someone say something? Okay. Oh, got a new thing in the chat. Is the runtime speed based off the components of the PC versus the Mac? I actually do not know. I've seen a computer file. And so for those of you that don't know what that is, you may have heard like a filiac or a file. It means someone likes something. So a computer file is someone that likes computers. Well, they have a YouTube channel and a website, and they have actually run tests for this and with different languages too. So they could see, and they could not determine whether or not it was actually the components. They theorized it was the components that were put into it because a PC, which the term PC is actually from IBM. It's not, but we use it in general for anything that's not a Mac computer, honestly. But the PC can be built from taking components from all these different manufacturers, right, and put together. Whereas with a Mac, it's components taken from Mac and put together to make it. So those seem to be more streamless when processing data and transferring data from one part to another, even with input and output. So that is a theory on why it's faster. There's still nothing set in stone on that. Um, so yeah, that's a great question to ask though. That's also why it's harder to. That's why Mac products are more expensive. Just in case you were wondering, that's why. Because you can't just go out and get any. I don't want to say any run of the mill, but any run of the mill device to for it to be compatible with, because it's every piece of it is coming from them directly. Whereas PC, you can go get anything, and they made it that way so that people would be more, would have the ability to be more versatile, uh, and to make it their own, like a true personal computer. Okay, so as I mentioned in the syllabus, that those resources, I said there will be links in the syllabus and other places. Well, here's the other place, class resources. And I had decided to, if I wanted you to go to a specific book and read certain sections, I would even put that within that week's module so that you'll see, oh, I probably should read these, or I probably should go to this resource. But there are links here. Professor Steady has done a series on YouTube for CIS150AB / CIS150 for Python. He has a ton of other ones on C#. So that's his which he does for his Xamarin cohort. This summer we did some stuff for iOS, and he has some other videos on iOS development. He's just pretty much put a lot of work and has done a lot of things. And so if you go subscribe to his channel, especially if you're going to be at South Mountain and you're going to be in this program, it's a good idea to go to that. I know students that haven't even taken some of those courses yet, and they would go to that just to get a head start, and then they would feel more prepared when they came into a course. So I try my best to use his videos because he's the predecessor with this course, and he had the most experience with teaching it at South. And too, because when he created all of this, he literally was learning Python at the same time. So he was trying to understand it as much to get a great mastery level of it and be confident enough to express what he's teaching. But because it was new to him, it's great to see sometimes those, because he would leave in his videos sometimes mistakes he made. He would be confusing it with another language, um, or just because it would just be a mistake. And so to see how we ourselves are human, like I'm gonna make mistakes just because I'm human. And even the version that we're working in is not the version I first started in. And I know personally that some features have changed, and there are some features that he'll mention in his videos that are, I'm not saying to say out of date, but they're out of date. And it's not, and he literally just made these. So just because there are newer things that people have created. And the great thing about Python, it's open source. I mean, you can go in and you can make your own changes and develop your own modules and those packages I was talking about. That's how we have game modules. That's how we have people that how they created GUI interfaces and created new functions for that. When I say GUI, I mean graphical user interface. That's how we're viewing everything on our screens. People have gone in and made new packages for that so that it would make life easier for other people. And sometimes I may even send you guys some videos on some stuff in regards to that. For instance, like when it comes to gaming, Pygame is a great library to import, and it has a great documentation. But some of their stuff looks kind of funky. But you can go in and make your own changes to it if you want to. You really can. But there have been some great games that like old school computer games that we used to play that would be 8-bit and so forth, that people have created and used. Pong is a great one. It's like a beginner one for people when they're using the Pygame library. People have created Pong games, and they've even created AI um, to for themselves. And what it does is it records what they do in the game, and it uses that data to play against yourself, like play against you the next time you come in. So it's you literally playing against yourself from the last time you played. And you see that the AI improves with the game because you're improving the game. And so it's really cool. It's actually a great training tool. But I'm getting maybe getting too far ahead. Uh, but anyway, so there's a couple of files on Python. And like I said, I'll be adding more. And I'll always try to pinpoint certain things like where you should read within a module. There's also a general thing about how computers work. The reason that this is here is because that's one of the competencies for this course. We're more focused on how the computer works in relation to us programming, because when computers speak in binary, ones and zeros, like yes to flow, no to flow, and when we program, we are writing it in a different language, and then it interprets that language into those zeros and ones, so that then the computer knows what to do, and that's how it knows how to display things on our screen. Um, so, which we'll get more into that as we go. But this is here as again just to fill in that hey, we did it, because I mainly want to focus on the programming. Okay, so one other thing, um, and let's say you weren't able to get Python running on your machine. The reason I suggest having it on your own personal machine is because what happens if your internet goes out? Well, you can still code then. You can still work on your assignments and things like that if you have it on your own machine. Technically, you could open up Notepad or any other text editor and type out your code and save it as a .py file. And there you is. You did your homework. So you could do it that way too. But you won't be able to run it to see if it is working correctly. I mean, you could. You could run it through your command line, and you can look up some videos how to do that. But sometimes you'll have the internet or you'll be in another location and you just want to, play around with stuff to see what happens and not necessarily try to pull it up on your machine or anything like that. Or maybe you want to do it from your phone, and you can on your phone, but you can if you're in a browser on your phone. This is a great site that I enjoy using, Replit, REPL period IT. The reason I like it is because it's free to sign up. And once you do, you can pick the language that you want to use and you can code it in language. And it has in the browser, literally right next to where you're typing your code, right next to it will be a window that you can just go click run and it'll run your code right there. So the IDE is right there in the browser, directly right next to where you're writing your code. So I suggest signing up for it, especially if you're going to really get into programming. They have tutorials on there as well. I don't think their tutorials are the best, but in my mind, they are the best with allowing you to have the freedom to code what you want. I mean, technically, you can code what you want on Code Academy and Solo Learning, any of those things, but usually it kicks back and says, hey, that's not the lesson. This is what you're supposed to be doing. And that gets annoying after a while. This way, you're more free. Um, all right. So, is using Adobe brackets. I use Adobe brackets before. Have you? So does that do the same thing? I have not used Adobe brackets. So the question was, does it do the same thing as Adobe brackets? So I have not used that, so I'm not aware if it does or not. So next thing I want to talk about why learn programming. So many in this class might just be because, hey, this is the requirement for my degree or my certificate. But you have been learning to program your whole life. You may not realize it, but you have. When you learn how to tie a shoe, or when you learn how to do a certain dance, like when you were taught how to Dougie or whatever it is, um, you were learning programming because you were learning a set of rules to follow, and you also learn how to follow them. When you give instructions to someone, you are giving them a program. You're telling them to do A, B, C, then D. Because if they do A, B, and then skip to D and then come back to C, it may not work at all, right? It won't it won't provide the intention that you had originally. So sorry. So whoever that was, I just muted you. If you have something to say, you can unmute yourself again. So no worries there. But yeah, so that's why we're learning programming. And then you can think of it too nowadays. If you understand, just like I said, if you know one language, you can you pretty much know them all, because then you just have to learn how to translate to that language. So you use their syntax, their types of functions, and things like that. But everything that anyone does nowadays has something to do with the computer. And even more so, it's becoming more evident that it also has something to do with programming. And so just knowing how to program, not how to code in a certain language, but actually program, meaning understanding what is happening, taking that problem and coming up with a plan of how to solve it, and then coding and then testing it and bringing it out, and providing the documentation and instructions so it's easy to understand for the person. That is what's essential in this world. And that skill can be translated to any field that you want. It's the only one that can. You will find tons of videos online from professional basketball players like Chris Bosh. You could think of the big tech people like Bill Gates and Mark Zuckerberg from Facebook. Jeff Bezos. You can look at all of those people, but I'm talking about like in real life, people that don't do anything that in your minds would have to do with that. There are baseball announcers. There's one for the Braves named Cal Tate. I actually went to school with him, and he was actually my TA in my Python class. Um, but he is a voice actor and he's a baseball announcer. He has a couple of radio shows. What does he do with anything that he learned with programming? Well, actually, he uses that to do the security on the back end for his website. And he also created his own website. He didn't have to go out and pay anyone to do it. He was able to do it himself just because of a simple skill that he learned when he was in actually his freshman year of college. So there are tons of opportunities and uses of programming, and not just with straight up coding. But career wise too, it will open so many doors. When I graduated, I became a high school teacher for mathematics. I had a coding club, math club, and a couple other things that I did at the school. And then I left and became a tutor. And what I tutored in was math, chemistry, physics, Java programming, and literally, I decided, I kind of want to try something else. I want to get back to programming. And I got a call from someone. I didn't have to seek anyone out because once that's just on your resume and just out somewhere, when they see that and they see programming and they see an object-oriented language, they will grab you. And I got a call for a job opportunity right then and there. And it was in a language that was different from any that I learned because it was an in-house language, meaning that that company created their own language to use, and it was an object-oriented language. Um, and so I was able to take the skills I learned to this new language that no one would have ever been able to teach me before because you only could use it in-house. Um, but yeah, but in regards to IT and the using development, this is one of the top 5 choices or top 5 careers, and it's continuing to rise because it's needed everywhere. Students are getting jobs straight out of high school because they know one language, because they know that they can once you know one language again, you can translate to another very easily. Um, the pay scale, because of that, though, has also decreased, but it still stayed pretty standard and solid. So you could get a job at least 50,000 right off the bat. I know there have been students that have come into some of these cohorts at South Mountain and gone straight to American Express, and go to about 70,000 after 6 months. So if money is a part of your influence for doing it, that's fine too. But again, it's an integral part of anything, any language. So you're also able to develop and demonstrate analytical skills. So being able to process to a problem and come up with a solution and planning it out with great instructions. And it's a lot of fun. So let's see. Go to the next thing here. I want to talk about what makes someone great at programming. And you can read through these documents as well on your own, but I'm just kind of going in general. So what makes someone good at programming? You don't have to be a rocket scientist. You don't have to be one of the smartest people in the world. You don't have to even have taken a computer apart, put it back together. That has nothing to do with being able to program. So a good programmer is someone that is analytical and thinking. So you see a problem and you think about, how do I get to the solution? Well, everyone has the ability to do that. No one is necessarily more. Some people may have more talent at it naturally, but everyone has seen a problem and decided, I want to overcome that, or has had an idea and they've decided, I want to do that, and they have gotten to it. Right? You signed up for this class. You can be an analytical thinker. Having great passion for it. So I don't know if you can tell, I've talked about different things that you can do with it. I've talked probably too much about it, but I'm very passionate about programming, and especially about Python. So being passionate about anything you do, regardless of what career you go into, it's gonna make you great at it. It's gonna make you better at it, because when you have a desire for something, no matter what your natural talent is, you're still gonna come up higher than someone that has like the greatest amount of natural talent in something with zero desire. You will always surpass them at some point. Great example of that, and I love using this example, Michael Jordan. Michael Jordan was a great basketball player, right? He had some talent naturally, but he worked his butt off. He didn't make it initially on some teams. I believe high school was like the famous one that people like to talk about. There's other stuff too. And even look at baseball, like, right? People used to ridicule him and laugh at him, but he worked his butt off and made it, um, and got moved up very quickly in that minor league. But it was because of his passion. It was in his desire. It wasn't his natural talent that did it. That played a part, especially with basketball in the beginning. But because of the desire, it just pushed it through the roof and made him who he was. Um, we see a lot of people flop when it comes to having a lot of natural talent, but not really necessarily a desire. For instance, I love using this example too, because I have a signed picture from with Michael Jordan and Allen Iverson. I don't know if many of you know Allen Iverson, but he's quoted with the practice, talking about practice. Practice? We're not talking about the game. We're talking about practice, because he didn't go to practice. He wouldn't go to basketball practice because he thought it was unnecessary. He was too good for it. Um, well, he was great. He had a lot of talent, but he flopped out real quick because of not as much desire. Um, and also this next thing, diligence. I mentioned all those different websites you can go to do tutorials and stuff. You know how I learned about them? Because I wanted to keep up with my skills. And so I kept at it by going to these different sites. When people would mention, oh, I learned this code from this website or from this seminar, ears would perk up and I would jump on it. That way I could stay ahead of the game. I mentioned in like the some of his Steady's videos, even though he just made them, they're out of date. I know that because I've continued to stay up to date with stuff, um, for the most part. There have been times where I've been, in my mind, way too busy to do so, but even still, somehow I magically find new things. Let's see. Resourcefulness, being able to know how to Google search is a great thing. A lot of times people think that I learned Python, so I must know every function that's built into this and every method, and I know everything about it in order to be successful at it. No, there's not a single programmer in the world that will tell you that they know everything about a language. Even the ones that have created it themselves still cannot say that. Well, you know what they do? They know how to find a resource, or they know how to, most of the time, Google search what they need to in order to get to a solution to their problem. Maybe they know what it's called, or maybe they know part of the process, but they're not sure how to code it exactly. That's what they do. That's what we all do. And people do that for everything. Like, you don't know how to do something, or you can't remember how to do something or a certain word, you Google search it. It's like the first thing anyone does. They pull their phone out like instantly. Do you know that? Oh, let me look. That's exactly what happens every time. So, and then the passion just to keep learning. And um, this last part about creativity, I actually like to think more of it as it's about you having fun, not just learning it for the sake of learning it, but you want to learn it for a use in your own life and see where you can and just have fun with it. The last part here, the soft skills. I know people don't really like that term anymore. It's not PC, I guess. Um, but it's really just about communicating. And with programming, many people think that programmers are not good communicators. They just sit behind a computer. That is never the case. Those programmers don't make it in the field. They are not successful at a company. They don't move from like the debug section to being an actual developer. I can tell you that from experience. I've seen it. I've seen people that in my mind, are much better programmers than me, but because they couldn't communicate well, they were stuck in the back of the house, and they never moved forward. They didn't get the raises and things like that. The reason is because no matter how much technical skill you have, you need to be able to communicate that to someone else. Um, for instance, if you are taking a problem from someone, or someone has an idea, you need to be able to translate their idea to code somehow. And you need to be able to say, yes, I can do that in this language, or no, I cannot because of this, or I need you to provide me this so I can. Like, you need to be able to communicate those things without going into, well, on line 13 of this code, because of da da da. Because a lot of people that may employ you won't necessarily know that stuff, or they don't want to hear it. They just want to understand what is the actual problem and how to get to the solution. So, with that in mind, make sure you ask questions. That's also part of communication. No matter how seasoned a developer you would be at any company, any location, you still need to be able to ask questions and be willing to ask questions when you don't understand something. If you know a lot, and you say, if you get through this course, you never ever have to ask me anything, that's completely fine. That is great. That doesn't make you better than anyone else that's in this course that completes it as well, but that is great. But I hope you still ask questions in the future when you need it, because if you think that you have to somehow always figure it out on your own, you don't. And there will be times where you won't be able to. And it's much faster and easier sometimes to just go ahead and ask the question. You won't look stupid. Um, yeah. Okay. So let's see. There are a couple of videos that you'll see as well. Again, like I mentioned, Hastedi has made a ton of videos, and I try to incorporate them in the course as well. Um, and they're here for you to watch. I won't play them all the time in class. I'm trying my best not to at all, because I want to get into programming and be able to allow you all to ask questions and see it in action. Especially today, with it being the first day and you having 2 homework assignments due by Sunday. But I just kind of want to give an introduction to programming. So I mentioned about like having a problem, um, and then coming up with a solution. So I like to think of it as construction. And I know he likes to use the example of Apollo 13, if anyone's ever seen it. Um, I have not, but he loves to show this clip even in our meetings as faculty members. There's a part of Apollo 13, which is a true story, but in the movie, it's greatly depicted. If here's this issue where these people are, they have to, it have to be in a one-man space with 3 people and somehow survive. And so they have like right after that, and they discuss what they need to do. They're like, we'll have to do it. We got to save them or whatever. All the scientists come into a room and they all got this carrying stuff that looks like they just got junk, like tubes and like plastic bags and like a suit, like a space suit and all these weird stuff. And they just like plop it all on a table. And then the lead guy says, all right, guys, we have however many hours to save these, to keep these men alive. And the only thing they have available to them is everything on this table. So how do we save them? And so what that is he is telling them, here's all the materials we have, but the problem is we need to be able to have them be able to be safe and be alive still. So they have to figure out how to take the stuff that's there and construct whatever they need in order to help those people survive. And that's what programming is. You start off with that problem, you begin to plan it out, and then you begin actually developing it. In our case, that'll be coding it. And you look for any possible issues or errors. That's in our case, that'll be debugging. And then you continue to test while you're debugging. And then at the end, you document so it's clear communication on the steps that someone needs to take or what is happening with the construction that you created. I actually have a great example of this. Recently, I had a baby shower for some friends, and their child's name is going to be Noah. And so we had a whole Noah's Ark theme. And what I did was I had one of the games that I had was Noah's Ark. You had to build Noah's Ark, and not the like to scale version because that would have taken way too long. But they had to just build whatever kind of art they wanted, and they had to have they had wood, they had string, they had glue, they had paper towels and napkins, and then they had to also incorporate 2 animals to be on it, and they had to sail across this little pool that had fans blowing and sprinkling water on it. So they had all these. They had these. They knew what the problem was, and they went to town. And some of them got done quickly, and some of them got done. After they had like 30 minutes. They took an hour because they just had so much fun with it. Because they're like, oh, I tested it, didn't work, and they had to come back in and rebuild and like think about why it went wrong. So, but all of that is programming, and I love using construction as an example because you can kind of visualize it because everyone has at least built something or seen something built or at least thought about how something's made. Well, there's programming involved with that. So I definitely suggest watching that video to you. So next thing, and again, this is another one of our check marks to say, yes, we went over this in this course because it is a requirement from the competency. But the software development lifecycle, I'll talk about that and a portion of it, which is the programming development lifecycle, because these are important in just in life, period. Like I said, you can take any of these skills and put it to any career that you do in life. It doesn't have to actually even have to do with coding. But software development lifecycle is having a problem or a need or idea and then beginning to plan it So whenever you plan it out, you want to see, is there anything else that you need to incorporate with what you're doing here? So you gather input from any potential stakeholders. Those stakeholders are the programmers. Those stakeholders are the people that came up with the idea, the problem, the designers of it, the customers that you have, the employers at the company where the programmer works, and of the customers. Um, those customers could have customers. So you want to get as much input as you can from anyone that is a part of this and brainstorm and then plan it out. Once you do that, you go into designing, and sometimes you have a separate person that does the designing. A lot of times people like to do storyboards, or they'll do a life flow of workflow so you can see it drawn out, how to get from A to B, so get from your start to your solution. Then comes the development cycle. And that development part is actually where the programming usually comes into play, because then you take that problem and the plan that they gave you in design, and sometimes you have to create a plan for yourself on will you get through the design process. Then you code it, then you debug it, then you test it, and then you document. And then it goes back to them, and then they can test it, because they may have had that development split up into multiple people having to program different things. They have to bring it together and see how it integrates within their own testing. Once they do that, it may go back to development and come back out a couple times. Then it goes through deploying, so actually sending out to the customers to actually begin use. Then it goes down to maintenance. So any bugs that may come up, it may go back to a support group, and then they just write fixes and things like that. And then make maintenance, and then they may see eventually that we have all of these bugs that we didn't catch earlier on. It's time for us to take those back through here and come out with a new version of it. Now, all of this used to be done, and in some places it's very frowned upon now, but some places it still happens. It was in a methodology known as waterfall, which meant that you start here and you go all the way through this process, put out your result, and then guess what? You start all over again and you come all the way through this process. Well, now we use something that's called an agile methodology, and the way that works is that you have teams that come together to look at each solution, and those teams work at each one of these aspects. Like, you may have someone that works directly with stakeholders all the time, pulling and inputting information, gathering input from those stakeholders. You have someone else that does the design, someone else that does the development portion of it, or maybe a group of them. You have someone else that does the testing, and you have someone else that sends out the deployment, and then or you may have another person that just works on support and maintenance of that. And the reason why this works better than waterfall is because instead of one person or one group handling everything, now you have people designated in each area, which means that this can continue to happen all throughout. Like, you can have the first thing it goes to, once it gets to the second person, he can now pick up something else, and then it can continue down a lot faster than the other way, where you had to wait for everything to get done together before you send it out. Now we can have small batches go up to a customer. Okay, so are there any questions about the software development lifecycle or the programming development lifecycle? No? Okay, cool. Nope. All right. So here, move on from there to uses of Python. So I kind of mentioned a couple of them already. A lot of people use them in web, so you can actually use it to help code your HTML for a web page. You can use it on the back end to check for, is this person gave this login information, is this correct? Does the username go with this password? Or as far as, hey, this IP address matches to this username and password being used. Have you guys ever been on a different computer and log into Google, and it says, hey, this is not the computer you usually log into? Well, that's what it's doing in the background. It's checking that. So that's the web backend of things. And there's other things you can do with that too. We used to do this project, and I had actually a friend that went further on with this. He actually ended up creating an app from it. But what we would do is we would go to weather.com. We would set up our Python code to go in each day. It's pretty much, we just have to run a code that would go in, pull up the temperature, and it would plot out Atlanta, and it would give the high low, and then Macon high low, and then it would just do it automatically for us, because there's tons of information on that site, right? And you have to go do a search sometimes to get to what you want. why not just create some code that's it was very simple too, that's just going to go in and search for those names, and it knows where to go to pull the numbers, and then just print it out, format it how you want to output. Um, and one of my friends did that because he was a golfer, and he ended up doing that as a app. He made that as an app that he would use for golfing, so he could know like what the wind speed and stuff would be. So he got more specific things he wanted, not just the high and low. And his friends would use that, and they would be a better golf team. At least that's what he would say. Uh, but but also this can be used in data science. That means the analysis and the mining. With the data analysis, it could be used to create graphs. Like yes, you can actually create graphs using Python code. And you can have visualization, so you could see everything that you needed to. You can also use it to find zeros of a line. There's a lot of different analysis that you can use. Data mining, so being able to sift through a bunch of data and information and find exactly what you want. Machine learning, I kind of mentioned that earlier with the artificial intelligence, with the Pygame, which a lot of people are doing kind of as a beginner to using Pygame, where they're creating a Pong game, and then eventually they create the AI that is really taking all the times they've played, and it's learning from that, and then each time you restart it, it gets better because it's becoming you. But it's always the last time you played the last time you played, it's that version, or the most up to date. So it's actually learning, but it's learning based off of lines of code. And usually statistics is involved with that. There's also stuff that kind of creates a neural network. It's called deep learning. So like Siri for you Apple users. I always forget the girl from Halo for Windows name. Rena, is that right? Anyone know? I don't know why I can't. I mean, I could just literally go to start menu and look up the name, but Cortana. Thanks. There's like two of you jumped on that real quick. Thank you. Yeah, thank you. Yeah, Cortana. Um, but yeah, so that is really deep learning, because what it does is it's not just here's a line of code to do blah. It is actually learning how to think for itself, like to even get to the point to interpret what it is that you may want to say, like whenever you're typing, um, or like maybe you're texting or writing an email or something, and it just can complete your whole sentence, right? Or I've seen it where it's almost I probably, because I'm bad at this, I may type the same stuff a lot, like in a whole paragraphs, but it'll actually put out almost a whole paragraph for me sometimes. So yeah, that's a part of that deep learning, and there's even more involved with that. Um, but yeah, it's actually really cool. I don't know if you guys have seen where um, the videos where you may be speaking about something, and then all of a sudden all of your like when you type anything into Google, it tries to link it back to that. Like it's just learning what it is that you like, or like the type of searches you have. Example, like sometimes if I go type, like right now I'm talking about Python a lot, right? If I go type P into my browser, that's going to be the first thing that comes up. um, but also used in cybersecurity, Internet of Things, game development. I mentioned that before. Raspberry Pis, one of the languages you can use on a Raspberry Pi and Arduino boards. Those are like little mini computers. So you have your little motherboards with their CPUs and things like that. Raspberry Pis are really popular right now, and they've actually increased the uh, enthusiasm for learning programming, especially with Python. Um, but people use Raspberry Pis to make their own cameras, to make their motion detectors, to be kind of like the rings. I don't know if you guys know what rings are, like the other doorbell stuff. I have a friend that would create garage doors openers from Raspberry Pi. So he would have a 1 Pi board. Um, he would have the Raspberry Pi attached to the garage, and what it would do is it would tell it to begin pulling up the garage, and he just would Bluetooth in. So he would use the phone, and he could call the number they had to attach to it, and then it will automatically open the garage. Um, he uses to create your own operating systems. That's where he was going to make personalized operating systems for people, otherwise known as POSs. You probably have heard that if you worked at a restaurant, or if you know someone that worked at a restaurant, they use a POS system. It's called a personal operating system. And used in mathematics. I think I mentioned that before, but um, if you were into numbers, number file, they have a site and they have a YouTube channel and stuff like that. But what they'll do sometimes is like if you want to know what's the largest prime number that we have of a certain kind, well, they don't sit and just like have walls written with numbers, like in the movies. They create a program, and a very simple program, but you just have a machine that is able to handle how many tests you need to do. Example, I did this actually. I wanted to estimate the digits of pi, and I did this when I was a sophomore in college. And so what I did was there's a pretty simple way to estimate pi. It's based off random number of times you hit within a portion of a square. And so if you do it as a quarter circle, you would be out of divided by 4 because it'll be a fourth of a circle. But anyway, that's digressing. But anyway, you want to see how many times it randomly hits in or not in side of that arc. But my computer, I was doing like based off of 100 different tries, based off 1,000 tries, based off 10,000 up to 1,000,000. Then when I tried to do 10 million, because I just jumped real quick, I was like, oh, I did 1,000,000, I'll probably be able to do 10 million. And it was taking a while. It's doing 10 million trials. That's a lot of trials, but it'll be fine. It crashed my computer. So had to get a computer that can handle more. Had to connect 2 computers to actually be able to do that one. And have it save at certain points so it could then start from there. So it would be less trials it was actually doing. But I had to finagle around it so I could get it to work. But that's a cool application that people actually most of the time they use Python when they do it, because of how easy it is, and there's other reasons too for that. But yeah, to use mathematics. So there are a lot of uses for Python. That's just some very basic ones. The ones I could think of off the top of my head when I thought this topic, because again, this is one of the things we have to actually talk about in this course. It's one of the competencies, but there are tons and tons of uses of Python out there. So next thing is, why should you learn Python? Like I told you, for me, it was the gateway drug. Also, it's becoming the most common language used. It has so many avenues and uses, so why not? If you're going to do anything at all that ever has to do with coding or programming, learn Python. It's a great way for you to pick up learning programming, period, so you could then go to other languages. And also, it might just be the language you end up having to use anyway. So history, you guys can watch this video on your own. I'm not going to do that because I do want to spend at least the last hour that we have actually getting into the application and opening it up. Yeah, we're good on time. But it is an open source language, meaning that it's free for anyone to go in and use or take portions of it and make changes for their own. That was the reason why one of the reasons why it's so popular to begin with, because you can customize it to your own needs. But if anyone's ever seen Monty Python, or most people at least have seen the movie Monty Python and the Holy Grail, they had their own like TV shows, pretty much kind of like SNL. SNL made movies, different movies based off their characters. It's kind of like that. It's like a British SNL. That's my easiest way of describing it. And I have been ragged on for saying that many times. Like, no, it's so much better. I will not agree or disagree because I know people like their SNL too. So I'm just not into that stuff that much. But it's a sketch comedy show. And sometimes in Python books, and sometimes in codes, and even certain functions you use, they're all jokes tied back to the show. And so the creators were big fans of it, and people that have continued to make their own or add libraries and modules and packages to Python have continued to keep that initial love of Monty Python alive in their own way with documentation and stuff like that. So that's the history. And again, I would encourage you all to watch that video. But now I'm gonna ask that we take a stretch break. And by stretch break, I mean I'm just literally gonna stand, I'm gonna stretch and then probably sit back down. And we're gonna move into actually using the application live. So I'm gonna stretch. All right. Any questions from anyone before we get into this? Get you your water. Okay. So you will notice on Canvas that everything that we just talked about and went through also has a video or even attached to it. So if you want to, you can go look at those. Those that are labeled as view are the ones that I mentioned how you should go definitely look at this video yourself or what. So you just pretty much just have to open it and view it, and that's it. If you don't watch the whole thing, I'm not going to be upset. Or if you don't read the whole thing, I'm going to say they're for you. And I have already covered them to the basis that I feel at most I need to. But I do suggest going back and looking at some of those. The first assignment after that, assignment 00, you have enough to begin it. It is all about workflow. So that idea of the software development cycle, an idea and then go into the plan and then the design. It demonstrates that, and Steady does a great job of demonstrating that, and then giving you an example, which shows a lot of code that we won't look at for quite some time. So I'll use this in a different way. But the idea behind this is just really so he gives you the code and everything. But the idea behind this is just so that you definitely know that your application is working. So speaking of which, your application working, go back to my model. We're gonna open it. So I'm gonna go to my Windows screen here. I'm just gonna open Python. I'm gonna type Python, and then it popped up on the other screen. But you should see something that says IDLE. If you want to go through it through the start menu and scroll down to P's, you'll see it here, IDLE. Okay. And so when you do so, you will see a Python shell. And so this is similar to your command line or terminal, where if I just wrote stuff in here like 5, press enter, comes out 5. If I were to do 5 plus 5, it comes out 10. So it's literally just running the line that it sees there. And so this is a great way to start understanding programming and what it does. Just off the bat, you may see, or you do see that I typed in a number and it gave me back that same number. I typed in a number plus another number, and it actually gave me the result. So that should let you know that Python understands mathematical operations. Here, I'm going to type my name, Christopher. What's all this red stuff here? Trace back most recent call last. File, the PyShell, line 1, Christopher. Name error. The name Christopher is not defined. I guess it's because there's so many of us out there. That's probably what it is. Let's come up with a more special name. I don't think anyone has that. I gave the same error. Why is that? Oh, well, the reason is because it's exactly as it says. That name is not defined. Well, how do I put text in here? Well, just like you would in any other language, you have to denote that text is text. And in our case, we'll call it a string, and most languages will call it a string. And the way we do that is by placing it in quotations. So I could do single quotes. I could do double quotes. I could do triple quotes. Doesn't matter which one, it's still a string. Okay. Well, earlier that 5 didn't come out with these quotes around it to let me know it was a string. It had no problem with that. That's because Python actually recognizes the number 5 as an integer automatically. Now, what other kind of things do you all see when, and this is an actual question, so you can either type in the chat or unmute yourself to answer, but what else do you see besides numbers and string in like, or not numbers, besides integers? So just like whole numbers and strings. What else do you see? Dates, okay. Someone said dates. What else do you see? just not necessarily here, but period. When you look on the screen, what do you see? Decimals, dates and decimals. All right, good. All right, and symbols. Yes. Version type and text. So there are dates that we have. Now, in some languages, a date will have its own special type. In Python, we don't have to worry about that because a date is just is written with numbers, characters, or I should say int values and other characters, integer values. Someone mentioned decimals, and I'm glad you did, because a integer is it can be equivalent to a decimal. We understand that. Like 5 is the same as 5.0 or 5.000 or 5.00000. Those are all equivalent, right? However, they are not the same to our computer. So one's an integer value and the other is a decimal value. So the way it's represented is much different and actually will do different things. So I'm going to put 5.0 here. Notice that it puts 5.0 out. These are different. One is known as an int, stands for integer. Those you all may be familiar with integers. Those are our whole numbers, positive or negative. But then when we use decimals, we have what's known as a float, F-L-O-A-T, and that's because it has a floating point, meaning it's allowed to go past that decimal and further out. So symbols, so those are characters, yeah. So our characters, we have many different types of characters, and there are characters that you can't necessarily type in here. So I'll give you an example. Christopher, and I'm gonna press tab and then put Stevens. Oh, that's not working. It's opening up something weird here. Well, that thing that's opening up is a list of files that's available to your PyShell, but I can't put tab in here. Well, actually I can. I can do what's known as an escape character. Notice it's the slash going the other way. So some people call it a forward slash. I've heard it called a backslash. I've heard people argue that this has been ended. This discussion has been ended, that this is totally a front slash. And I still see documentation that says otherwise. So I don't know what to call it, but other than an escape character. So Christopher, I'm gonna do an escape character, and I'll put T, and then I'm gonna put Stevens in here. And the reason I'm doing that, oops, gotta put my actual Steve in there. Let me see. It does this one. Oh, I haven't told it to print yet. That's why. So I'm going to show you a function that's used in Python. It's called print. And what print does, and the cool thing here is you get a little screen tip to tell you how to use it. But you put a value in here, and there's some other things that you can do as well. But I'm just going to put in what I just had. Let's see. And I'm going to do it this time with this guy here. And there it is. Okay. And let me recall that same one. Oops. Come on. There we go. Copy, paste. Okay. So within print, print takes a string, or actually, let me say this again. Print takes any value and returns a string, print it to the line. So in this first case where I did that, it's still solid as just that string because it doesn't understand that escape character is supposed to be anything special. When I use it inside print, print is a way we can format. We talked about we're supposed to be taking user input and then giving a formatted output. Print allows us to format it in certain ways. And so it returns it as a string that will be seen on the screen. And so in this first case here, I didn't use print. So it just saw the escape character as just regular string. So it's just characters to put in here. Print, however, allowed me to plug this in, and I use this escape character in. This in stands for a new line. So at this point, it sees it, it says, hey, I need to go to a new line. Notice what it did here. It went to a new line. Something else to notice is there was space in between these. That space is still there. See that? And then that tab one that I mentioned earlier, \T. So y'all can see that. Space, tab, another space. exactly what we wrote here. Print recognized this as an escape character and knew that it needed to format that output in that way. Okay, so this is just the base. This is just some basics that we can do with here. I wanted you to see that we had certain types. We had an integer type, so for our positive, negative, whole numbers. We had a float type, so we can use decimals. Then we have our string, and within our string, there are special characters that we can use to help format it and how it's printed out. So there is another type that we'll be looking at in Python, and it is so very important to know and understand. And it is actually a common testing question. How many of you have ever heard of true or false? Kind of a joke, but you all have used true or false, or you understand what true or false is. If something is correct, you say true. If it's not, you say false. Well, I'm just going to type true or false here, and you can put in the chat what you think is going to be the result. Is it going to be true or false? Maybe you're doing it on your own and you're going to already have a deep way into the answer. But I kind of want you to guess beforehand. If when I press enter, is it going to say true or false? Anyone? False? Got some people think maybe false. Okay, so privately people are saying true. All right. Not defined again. Some of you have already know what this is actually called. So let's see what happens. It gave a true. The reason is, and this will answer someone's question, they actually said this is a Boolean. Do we not have to define a Boolean? In Python, we don't. We can literally just straight up type true or false. When we evaluate something, it will give an evaluation of is it true or is it false? So that Boolean is already there. We don't have to, yeah, it is really cool. We don't have to say that what I'm about to type is going to be a Boolean. Just like we did up here, we didn't have to say what I'm about to type is an integer. I'm going to put 5 here. So give me back the integer 5. We don't have to say this is going to be a string. Then I'm going to put Christopher. So give me back a string version of Christopher. We don't have to say this is a float. Give me back a version of float. In most languages, you have to typecast. Now, some of the newer ones, just like Python, they make assumptions about what you type. For instance, I type 5 up here. If I want it to be a string, I literally would have to say this is going to be a string. So I would have to type in 5 inside of a string in order for it to become a string. If I just type 5, it's going to give me an integer regardless. But I did my true or false in lowercase. It gave back an error. Good. I'm glad you did that. So someone said, hey, I did my true false in lowercase and it gave back an error. That's because in Python, in order for it to be the keyword true or the keyword false, it needs to be capitalized, right? Just like the example here. Okay. So I want to keep this somewhere so that you guys can see it and while we're going through it. So what I'm going to do is I am going to, because this is in the Python shell, like I said, this is kind of like your command line. You type some stuff in, it runs the line. Type some stuff in, run the line. Type some stuff in, run the line. It's not, what if we want to do a bunch of things at one time? Well, this wouldn't be there. So how can we do that? Well, we can create a file. So this is where we get our .py files. Remember I said earlier, if you want, you could even just use a text editor and save it as a .py file. We don't have to do that though. We have Python for that. And we can create through the shell, we can go to file, create a new file. And what I like to do is I like to document while I'm doing something, or I like to do it and then go back and document. So I'll talk about what I mean there in a second. But what did we do? We looked at integers. So notice I put and I'm trying my best to learn how to say this. I put a hashtag in front of this. I'm so used to saying pound. But I put a hashtag in front of integers, and it turned to a red color. That's because this is a comment. So whenever you want to document something in code, you would use the hashtag or pound sign, and then that will allow you to begin to comment what you want to say. And so if I went to another line though, it's not red anymore. So I would have to put another comment line. We'll talk about multi-line comments later. But integers are our whole numbers. And I'll just say positive or negative. And then that's where we had just like the 5. So I'm going to print 5, and that's going to be an integer. Then we looked at strings. And strings are characters within quotes. And it should be an equal number of quotes. As you guys saw, I was able to do a single quote, double quote, and triple quote. If I did a triple quote here and a double quote here, it would give me an error. So that's something else to keep in mind. So I want to print, and we'll do this time the standard hello world. Most programming languages, that's like the first thing you ever type. My first time, I had you typing 5. So that's how you print that. And we're also able to do with strings using print. Using print, we can add special escape characters. Like tab, which was that, and a new line, or return character for those of you that know what a return is. So print this is a tab. But this is a new line. And then we also had floats that we saw. So float is a decimal. So print 5.0. And we also saw that we had Booleans. And so our Booleans were our true or false. Don't forget to capitalize. And we will see how these evaluate later on as well. So we can print true or false. And notice how that or is also a different color because it's also a keyword. It is literally doing the operation of or. And so if I were to ask you to answer true or false, and the question is this true or false? Well, I said it's true, or another option is that it's false. Well, that means that, of course, it's true. And that's why it gave us true as an answer, because at least one of the options is true. So it's going to be true. That's more about Boolean operators, and we'll look more at that later. But what I really want to show you is with this Python file that we just created, how it actually works. And so I'm going to go to run my module, and it's going to force you to save it before it runs it, which is great because in case you coded something wrong and it crashes, then things won't be lost. And you can save your information wherever you would like. A lot of instructors tell people to save it exactly where their Python shell is, and that's where this is taking me to begin with. I'm the testing 01, so this is the first week, so this is what I'm going to put here. It's a py file, and then it runs. So notice it says restart up here, so it's saying where it's going to find that information to put it. And the first thing it gave us was 5, because that was our first thing we told it to print. Trying to show you both of these things at the same time. Okay, so first thing it gave us was 5 because we told it to print 5. Then we said print hello world. It gave us hello world. We did this is a tab, and then it did that, and there's a tab here. And then I said, but this is a new line. And then see, it went on to another line. We did a float number, we got 5. And true or false gave us true. And so those are the 4 different types of data types we'll look at: strings, integers, floats, and booleans. And we'll use those throughout this course as well. Okay, so let's see. Don't want to lose it. Does it indent to make it easier to see a new line? No, it does not. It just puts it on a new line. Whenever I type a new line, I tend to do that. I've been told not to do that because it can be confusing to people, to be honest. So I hope that wasn't confusing when I did that. It does not automatically indent. I do that because it makes it easier for me to see, and when I'm showing someone, it makes a new line. The indentation I did was simply just putting a space there afterwards. So okay. So we went over print. We went over comments. So comments again, you use the hashtag to comment. Yeah, no problem. So we talked about the different types we have. So another cool thing about these types, and I'll probably just show you from the shell because it'll be easier. I don't know why this. So what I wanted to show you from the types, and yeah, I guess I'll do it here. I'll do it on a new one. Is that we can typecast using some built-in functions in Python: string, float, int, and bool. So what these do is whatever you put in the parentheses, it will turn into one of those things. It'll turn it into a string, it'll turn it into a float, an int, or boolean. Now, of course, some things won't be an option, right? If I put a number into bool, well, let's just actually see what happens. Oops, the bottom one here. Whew. Just returns true. But what I could do is I say, does 5 equals 4? It gives me a false. So within bool, it's best for me to actually put something for it to evaluate. If I just put in one thing, it's going to just say it's true because you're pretty much asking, hey, is this what it says it is? Well, of course it is. But let's look at some of the other typecasting. So I'm going to typecast to a string, and I'm going to print each of these. So I'm going to print string, and I'm going to put 5 into it. I'm going to print string, and I'm going to, sorry, not string. I'm going to print float number 5. I'm going to print int 5, which you guys know won't really make sense because it's already an integer. And I'm going to do the Boolean one again as well for 5. I'm going to run my module. Again, it forces you to save. So let's see what it did here. So what did it print? Well, at first it got 5. Then we have the float of 5. And then we have 5 again and print out true. So it converted it to each one of those types based on how we cast it. Now, at this point, that probably won't seem like much because if you're already typing exactly what you want, then it is already going to be the type that you want it to be, right? So if you ever want to cast it, why not just make it that to begin with, right? Because I could have, in much less typing, just put quotes around 5 to make it become a string. The Boolean one, I probably could have just typed true if I wanted to see true. Where this becomes even more useful is when you have variables that are saving your values, or when you have a collection of values, you need to test or look at or use multiple pieces of that collection. And so everything that you enter in is a data. So data is some kind of type of fact. Whenever you combine data together that's related, that's when you get information. That's what we call data information in computer information systems. But within Python, and as you would see in any other language, there are certain ways to contain that data. In other words, how do you save that data somewhere? Instead of me typing 5 all day, What if I want to save that as a value somewhere and then call uses to it later? Well, what I actually can do is set up a variable. In some languages, you have to say this is going to be a variable. Let's talk about variables. By doing var. In Python, you can just type whatever the variable you want to be. If I want it to be x, say x equals 5. If I wanted it to be some long word, I could do that. I can make any variable I want, as long as it begins with characters. Now, if you ever want spaces in between stuff, like number 5, instead of doing a space, I'm gonna do an underscore so it recognizes that. Some people will also do what's known as a hump case. The first word would be lowercase, and then the second will be like this. And I'm just using 5 because I've been using 5. If I want to put 6 here, it still would be saved under the variable number 5. Okay, I can put this to be assigned to anything I want. So these are just some examples of variables. So if I were to print x, print 5. Another thing, actually, in some language, you have to put spaces in between these. So if you assign a variable, you have to put a space, then it equals. You don't have to worry about that in Python. You can just type it straight out. It'll be fine. So I'm going to run this now. Notice that when I run, I can also do F5. So if you have that functionality available to you, you can do that. And I tend to do that myself because it's much faster. When I'm on my machine, school one does this often. Okay. So see how regardless when I print X, so I did it, that was 5, so on and so forth. So that's a variable. We'll look at other collections later in this. One of these student learning outcomes is using lists, tuples, and data handling. So that's what we'll look at. Arrays as well. One of my favorite things to look at when it comes to collections is that a string really is a collection of characters already. So we've actually already looked at something that is a collection, and we can access different parts of that string. We'll see how to do that in the future, that round. So so far we looked at comments, print, different types of data, and then containers. Thank you. Thank you. Oh, a couple of you guys said that. Thank you. I appreciate that. I sneezed and people said bless you. Appreciate that. So that we've looked at a couple. We've looked at comments, prints, variables. We talked about what collections are, and we'll use them in the future. About the 4 different types that we'll use: string, integers, floats, and booleans. We looked at typecasting. Are there any questions so far? I have to get through today, but I'm in no rush ever. I just want to make sure everyone's on board. Okay. All right. I'm going to continue then. So I've been looking at using a number a lot. I've been using number 5 a lot. So let's do some more stuff with. We already saw that we're able to do some, because I showed you earlier, you just type 5 plus 5 in and it worked just fine. Let's see that addition done. So I'm going to pick the use new variable. I'm going to do y, and this time I will not put a space so that you all can see that you don't have to put those spaces like you do in some languages. In fact, I'm going to go crazy and not put a space first and then put a space after. So what I will do is I want to print x plus y, and let's also print x minus y. Now those operations you probably have been used the keys on your keyboard in order to type those. But what about multiplication? Anybody have an idea of how I can type a multiplication symbol or tell the computer to multiply? Good. A couple of you went in on that. Great. So x and then an asterisk y. All right. What about division? Anybody got an idea of how to do division? Good. Good. Excellent. I love that so many of you all got that right. Yes, division, we will just do a backslash or the one that's next to the shift key, which however you want to call it. Okay. Not gonna get an argument between those two because we will use both of them throughout this course. So that's anyone have an idea of maybe how to do a exponent? Okay. All right, caret. Now, let's see what happens when we do a caret. Actually, before we do that, I'll do it over here because I can do it on the shell. Let's do 5 caret 4. Let's see what happens. It gave me a 1. Oh, that doesn't seem right. Maybe it's just the numbers were too big or something. Let's try that again. Now it gave me a 0. Huh. That caret's not working the way we want, is it? It's because it has a different use. And maybe you guys can do some research to see what that caret does. But for right now, how do we do an exponent? What we'll actually do is 2 asterisks. 2 asterisks will be used for exponents. Yeah, asterisks. So exponentiation is the proper term of that. To do exponents, that's what we'll do. All right, let's take a look at these guys. So I'm gonna save it, Control S, and then see if I got my guy working yet. Nope, still not working. Okay, don't know why. Trying to get my computer just to do it from a custom function, but it's not working. So that's everything that we had beginning around 5, 5. So here we are. Here's our first print statement. So we got 9 for x, 5 plus 4, 5 minus 4, 5 times 4. Look what happened when we did 5 divided by 4. We got 1.25. And then 5 to the 4th power, we got 625. I'm gonna look at this guy here though for a second. And there's a reason why. Some of you that have coded in other languages will probably recognize that this is kind of weird. We did 5 divided by 4. Now, remember that 5 was an integer type and 4 is an integer type. We didn't put any decimals or anything, but the result it gave me is a decimal, and it's the correct decimal. So it gave me a float as an answer, but everything I used was an integer. For those of you that have that may not have any programming background, you may say, I don't see an issue with that. Well, it is an issue because in every other language you've used, if you use an integer with another integer, your result should be an integer. Makes sense, right? They're the same type. Your result should be the same type. Well, Python understands that most people in the world, when you're dividing, if it can become a float, it's a float, right? If you type something in the calculator, if you would put 5 divided by 4 in the calculator and you saw 1 as an answer, you would probably freak out, or you would say, this is the worst calculator I ever had, throw it away, whatever. Python understands that, and so they made it so that if you divide 2 numbers, it's going to be a float. Okay, they did that to help you. Well, what if you want the way? You want the way that every other language does it, and that yes, that actually can be useful because sometimes when you're doing division, you only want to know what the whole number part is because that's what it should actually result with. Well, the way we do that is 2 backslashes or 2 of the slashes next to shift, whatever you want to call it. Okay. I'm going to put something else here. I'm going to put addition, subtraction, multiplication, and then this will be float division. Oops. And then this would be integer division. And so the way integer division works, again, it will result with the integer. So if it did give a float value, it'll give us the whole number part of it. Okay, it won't round up. It's another thing to keep in mind. It won't round it up automatically or anything like that. It will always give you the whole number part of it. That's very important to remember. A lot of times people think that it'll round up on its own or something. It will not. Then we had exponentiation. And all right, so we got a couple of things that you all probably have widely used throughout your life. Are there any other things that you guys may have used before when it comes to math? There's usually at least one more operation that's very common for people to use. Anyone? All right. It's called yeah, someone said it. Square root. Square root. That's a very common one that people use. So the way we do a square root is actually not a automatic key that's recognized. So the way we do it is actually we do a call to a special module that someone created that has a ton of math functions in it, and they appropriately named it math. So what I'm going to do is I'm going to do something that's called import math. What import does, it allows you to, whatever follows, you're telling it to go find that module and pull this in. So if I just say import math, it's going to pull in that entire math module. I can be more specific if I want and say I only want to look at the square root, and we'll look at the power one as well. We already have exponentiation using the two asterisks, but there's a power function as well. I could tell it to specifically just do those. So, but instead I'm going to go ahead and use it. So I'm going to have it print math dot, or actually I don't have to do that now. I can do squirt. So, and then I'll just do y and print squirt for x. And let's save, and let's get this guy to run. Oops. I did save it. Okay. All right, and then it gave me an error because it said squirt was not, did I put a space in there? I didn't. Got my math? Yeah. It says squirt was not defined. All right. But I just told you that if you import math, it has that function listed in there. Why is it not working? Well, sometimes you need to tell it exactly where that squirt is coming from, because maybe there's another function in your own file that squirt exists in. So I'm going to tell it I'm coming from the math module, math dot squirt. And notice even when I do that, by just typing math, what comes after with a dot, there's a list of all these math functions that appear. You guys see that? Tons of stuff. Look at that, gamma, GCD, that's greatest common denominator. These are all things that mathematicians use a lot. Logarithms, pi, finding the remainder. Look at that, that's a lot of different functions, right? All of that's available to you now. So I'm going to save that, and I'm going to run that. And this time we got no error. And look at this. It gave us a nice square root out to, I think it's supposed to be 12. Oh, did it go further? That's some places. Good. So, yeah. All right. Cool. Well, there are other functions as well in here, such as ceiling and floor functions. Ceiling rounds it down automatically. Rounds it up automatically. Floor rounds it down automatically. But I just wanted you guys to see how to use math functions from the math module. Yeah, so there is one more operator that I do want you to know about. It's actually one of my favorites. I use it a lot when it came to abstract algebra, and when it comes to number theory. And that is actually called a modulus. Most people do not know what this means. Does anyone know what a modulus is? You can feel free to unmute yourself and say it, or type it in the chat. I'm gonna give you an example right here. And the symbol is the percent sign. Oops. Yes, it is the remainder. So the modulus gives you the remainder of the answer. You may say, why would I ever want to know the remainder? I would want to know the quotient, right? Or maybe the quotient with the remainder, but not just the remainder. Well, if we want to know if something is divisible or not, we really don't need to get a result. We just need to know, does it have a remainder of 0 or not? If we want to know something's even, we just need to know if when we divide by 2, or if it is divisible by 2. These are good reasons to know the modulus. And there are a ton of other things too, to know what kind of grouping things will have. If you can divide it into certain groups, you could use a modulus instead of going straight for dividing. You can just look for what the remainder is. And there are a lot of other mathematical reasons. I don't know a lot other. There are some others I can think of on top of my head, but those are usually the basics of why anyone will ever want to use a modulus. Because instead of you computing whether you get a result with no decimal, nothing after a decimal or not, it's much faster just to say zero remainder. All right, so I'm gonna print those, or sorry, I'm gonna save those, then I'm gonna run it. So I did that modulus here and it gave us a 1 because 5 divided by 4 does give a remainder of 1. All right, cool. Remainder. Okay. So yeah, we have a lot that we've covered here. So let's move forward. So not much time left. So one other thing I'll actually say about these operators is that you can do something that's known as a compound operator. And I want to show you what that is like. So let's just say we had a z that was equal to 1. And what I want to do is I want to add another 1 to it. What I could do is do z equals z plus 1. Right? Well, that makes sense, right? Because I want to eventually have z just be 1 more than what it is. So I could say, hey, z is 1. Now I want z to equal itself, but add 1 more to it. Well, this is something used commonly. Usually when you have a counter and you want to keep it increasing, but this gets repetitive, and who wants to keep writing, the same variable over and over again? Well, there is an easier way to do this. Instead, what we can do is we can have it do z plus equals 1. And what that does is it says I need to do a special operation, but set it equal to the same variable. So in this case, it's saying I need to add this 1 and set it back equal to z. The result back equal to z. So you can do it with 1. Or sorry, you can do it with plus. You can do it with minus. You could do it with multiplication. You can do it with division. What else do you guys think you could do it with? Yep. You do it with, you can do it with subtraction. You can do it with exponentiation. Squirt. Well, squirt's not an operator like the others are. Squirt has to come from the math module. So there is a way for you to get it to do that, but it's not going to be in the sense that you're thinking of. It actually would be done using exponentiation. Someone actually wrote it after that's cool. So you would use the square root as a power instead. So and just in case you want to know what that is, and I'll actually show you down here. So if I were to do 4, or if I was to do math, squirt, and then 4 gives me 2, right? But if I wanted to do that as a power, I could do 0.5. Raising something to the 0.5 power or to the half power is the exact same thing as doing a square root. That's how you would get around if you ever wanted to do a square root. If you want to do a cube root, it would be to the 3rd power, and so on and so forth. So that's how you can get around if you want to do a compound operation and involve a root. That's how you would do it. You would still use exponentiation. And you don't have to use number 1 here. I could have it be do the operation with 2 or any number you want, or with another variable that has a number saved. This can even be used. Actually, let me show that over here. Let's say I have a string that was the letter. Actually, let's do the let's do an asterisk. Because a lot of times people like to use this example. So a string is an asterisk. So S is this asterisk, right? So if I print S, it gives me that asterisk, right? If I just put S by itself, it gives me that asterisk as a string because I said it's a string. Well, let's say I said S, or let's say we'll say let's see I don't know what I'll say S line. Let's call it S line. S line was equal to S times 5. It's kind of weird that I wrote that. I wrote a string times 5. Is it going to work? Oh, it didn't crash. Well, let's see what S line is now. It gave me 5 asterisks. So it actually did work. That's kind of weird, right? Well, if you were to take a string and say multiply it times a number, what it actually will do is it'll say, oh, you want this string listed against itself a bunch of times. So that's something cool just to play around and know. But I mentioned that because I said how you could do these compound operators between numbers. That's not the only way you can do it. You can do it with strings. You can do these compound operators with strings. Dividing them, that'd be kind of weird. I have never seen anyone actually use a divide compound operator when it comes to strings, but it could be a first for anything. But yeah, that's a compound operator. So if I wanted to, I could have said that S times equals 5, and then say S now and see it would be the 5 across. And that's how I could use that compound operator. But you can do this also with the modulus. This is another thing that people do in number theory to get down to numbers. Actually, one way that you can find to see if a number is divisible by 7. There's a special way you can do it. But yeah, you can use a modulus as well. So any of the operators, so addition, subtraction, multiplication, division, float division, and the integer division, exponentiation, and the modulus, you can do a compound operator with it. Okay? So got 8 minutes left, and there's 2 things that I want to talk about. One, I kind of already mentioned how we could do multiplication with a string and a number, and it would just have that string listed out multiple times. Well, if you can multiply strings, multiplication is just repeated addition. So that must mean that you can somehow add, and we can. That's called string concatenation. So if I had Christopher and I said plus a space, and I said plus Stevens, and I press enter, it'll make one string, Christopher space Stevens. Okay. And that's what string concatenation is. Now, there are other ways to combine strings together as well using certain functions. But there's 2 other things that I want to talk about. One of them will be how to format those strings, because remember, we want to format outputs. But the other one is, how do you get input information from the user? How do you receive input? So there's a function. So user input. So I'll just call it user equals. There's a function known as input. And so what you do for input is that you give the user a prompt, or you don't have to give the user a prompt. They just know to put something in. It's probably best to give them a prompt saying type something. So I say, hey, type your name. So by giving them that input, by giving them that prompt, whenever this runs, it's going to ask the user to bring some it's going to say type your name here, and it's going to wait for them to type something in and press enter. When they do, then it's going to take it back to this code, save it to user, and then it's going to do something. And let's just have it print user 3 times. So it prints the username 3 times, just for fun. So I can show you guys that this definitely works. So notice it went through all our codes that we had tell it to do, and it says, hey, type your name. I'm going to type in here Christopher. It's Christopher. Okay. A long time ago, I coded. You guys remember that song from Barney? I like to eat apples and bananas. I actually used that because I didn't want to keep typing eat. So I did the multiplication thing to do eat. But anyway, I don't know why I just remember that. Just thought it was funny. So that's how you take user input. Now, let's say you took user input. It's always going to give it to you as a string. Well, that's not good, right? Because let's say I wanted to get the user's age and do some things with it, right? So, how old are you? All right, save. I'm gonna actually comment out the other one just for the sake of time so we can run this stuff quickly here. Here. Oh, oh, it's because I tell it to print user. Boop. So see, I'm a human, I make mistakes. I forgot to comment out that one as well. Boop. It says, hey, how old are you? Let's see. I am gonna say I am 9 years old. Okay. Oh, that seemed to work just fine. What if I even told it to print the age? Or actually, I'm gonna do what I want to do. Yeah, let's do that times 5. So you're gonna expect for it to multiply that, right? So it's gonna take in 9, and we want it to do times 5. Let's see what we get for a result. 99999. It didn't give us 45. Why did it give us 99999? Because as I said, input takes it in as takes it in, and it returns it as a string. So its input is taking this as is saving age is being saved to as a string. So whatever was brought into it, even though we were expecting it to be an integer, it gave it to us as a string because that's what this takes. That's what this returns. How do you fix that? You can tell the user to put a number in. That's what they did. It still is going to give it a string. But remember, we said we can cast our strings. So I can actually put int in front of this. And so now whatever result they give us, it's going to go to an integer. So if I save that now and I run it, and I put 9 now it gives us 45. Because now it knows that, hey, that was integer. So what happens if you want to put 5 instead of 5? That's a great question. So instead of, if you spelled out the word 5 instead of typing a number 5, well, you would have to tell the user to make sure they enter a number, not letters. There are ways to also check for check to make sure they gave you an integer, which we'll get to maybe when we look at some if then statements and conditionals in a couple of weeks, or actually we may get to that next week even, depending on how fast things go. But yeah, that's what you would do. You would check what's given to you to make sure it is a number, and if it's not, you could have them prompt back and say, hey, those aren't digits that are used. Please use digits to give this answer. Or you could put that initially here, like in the parentheses, use digits, not letters, so that the user knows, oh, I should put in digits for this. Okay. All right. So the other thing that we need to talk about. Oh yeah, you're welcome. You guys can always ask anything that you want to ask, and you guys had great questions. So the other thing I wanted to talk about, we have 2 minutes left, was about formatting, because like I said, we want to format our outputs, and we've seen how to do that using like the tab or using a new line. And there's other escape characters too. But there are some ways that you may want to format your numbers, right? Like if I type in 5.0, it gives 5.0. But let's say I wanted money. Like if I type 5.00, it still gives me 5.0 because it's changing it to a float, or it knows it's a float, and that's the easiest way to write that, right? So how would I get it to actually give me 5.00? Well, what I could do is I could format it to do so. And there are a couple of ways to do that. So I'm going to take 5.00. The format function, it asks for the value, and then you give it the specifics of how it should be formatted inside of quotes. So I'm going to do this, it's 0.2F. And what this actually means is 2 decimals, and it should be a float. So if I were to do that, look what it did. It formatted into a string with 5.00. Even if I were to have put 5 in here, it still would do that now because it knows that it wants to be formatted in this way. There is another way to do this within a string. So you can use a percent sign within a string as a placeholder, and then outside of it, see, I'm gonna do that same thing I did before, 0.2f. And outside of it, within parentheses, put what your value is. So I do that, does the same thing. It says, hey, I see this percent sign in here, so this must be a placeholder for something, right? It goes outside the string and say, what do I need to bring in here? Brings in the 5. It says, how's it supposed to be formatted? Oh, to 2 decimal places, floated. There we go. So this percent way is like the way I learned back in the day, and it is the oldest way to format. There are newer ways, such as this format function. There's also a format method. So if I were to take a string and then see 0.2f like this. So what's inside of curly brackets, and then do a dot format and give it the number 5. That'll work. And so what that does is the curly brackets tell it that I'm expecting the format function outside of this behind a period, and it's going to tell me what to format. This 0 in the beginning is actually telling what it's telling it what index to format. We'll talk about indices when we look at collections, but this is the 0th index. The one after it would be the 1 index. So if I wanted to put like a, oh, I can't because but if I wanted to do like the same thing, let's see. And then like a comma 6 here, I could actually do something like this, put a 1 here, and that's it. And then it says, oh, okay, the 0th part, put in this first thing, but format it with 2 decimal points floating. And then this part says, go to the first index, which is the second thing you see here, and just put it in here. So like I said, parentheses, the percent sign was the way I learned it back in the day. The model that you'll see in the videos that Hastedi has is using the format method, either the dot format. Actually, I think using the dot format, because even this is a little older than this one. So the percent one came out first, using the format function came second. A dot method version of it came later. And then the newest method actually just straight up uses an F, the letter F in front of the letter F in front of it. Copy that. Trying to make it go a little faster because I don't want to lose you guys. Actually, I think that's straight up it. Yeah. So in this case, it takes the number that's given here, and then the format is literally given right afterwards. So if I wanted to say put the number 5 in here, I could do that, and then it automatically formats it. So this is actually the fastest way to get this done if you're looking at runtime. It's also the easiest. Like, hey, I want to format a string. I'm just going to put the letter F in front of it, and within it, I'm going to tell it what to format and then how to format it. So that's everything I wanted to get covered, and that's enough, honestly, to not just finish your assignment 1, because assignment 00 was the workplace one I talked about before, but not to just finish assignment 1. You honestly could probably get through assignments 2 and 3 with just everything we covered. This video, as soon as it gets done, like downloading and compacted with WebEx, I'll upload it, I'll send it through email and put it up on Canvas as well. So you can go through that. But the video, I gave you links within the module to the specific videos, so you didn't have to go siphon through the Python playlist to kind of help when you're going through some of these topics. But yeah, if you have any questions through the week, please feel free to ask. Their office hours are between 4 and 5:30. Same place, WebEx. So any questions before we go? I took 4 minutes extra of your time. I am so sorry about that. I really am. Time is precious. So any questions before we go? No? All right, great. And I'll revisit some of these last couple of topics at the beginning of next time. Yeah. All right. And you all as well. I had fun too. All right. Well, have a great night and be safe. And again, like I said, ask any questions that you may have. And I'll see you all next Monday, if not before an office hour.